In this next example, I have 5 doubles to demonstrate a few things to you. With the first double, we have 11 digits, and with double 2, we have these 6 digits from 1 to 6. You can also notice with double 1 that we have floating point representations. We do 3, the decimal point, and then we have the rest. This is basically the value of pi. Then for double 3, I do 1 to 9. For double 4, I do a really small number. And then, as I mentioned in the module C++ 101, we can also use scientific notation to initialize a floating point. So do 1.3e5. Then we want to see what the default output is going to be when we display that. So let me just go and build around that. Notice with double 1 we get 3.14159, for example. So we only get those 6 digits. With double 2 we get all 6 of those digits. And then you can see that D3 and D4 is actually going to display in scientific notation. Again, because D3 has more digits, you can see here it has more than 6 digits. And also with D4, and D5 is actually going to display fine. From these examples, we can observe the following. If the number of digits before the decimal point is 6 or less, then the following is going to happen. As we've seen in the previous example, if the floating point has no fractional part, then the number is displayed without the decimal point or any decimal digits. And you've already seen how we can change that to show the decimal point again in the previous example. We can also see that if the number of digits before the decimal point is more than 6, then the number is output in scientific notation. We get appended e plus or minus and some value. We can also observe that if the floating point number has 6 or less digits altogether, then all of the digits are displayed. But if the number of digits are greater than 6, then those after the 6th digit are lost. The final digit, that 6th digit, is rounded up or down. Of course, we're not counting all of the characters. We are not counting the decimal point or the sign, so plus or minus sign. I would like to note that sometimes with a small value, such as with D4 here, for example, if I go and remove a 0 and build run, that will actually display the value. So that can be confusing to some extent, but I just wanted to show that there is an exception. Sometimes that value will actually display. And also, as we've seen with double 5, even though we initialize this using scientific notation, that is not necessarily going to be displayed in scientific notation. So it's all about the precision. Let's go and look at how we can actually change the precision. I'll start off by using the member function on console output. And before I do that, I'll actually just go and copy and paste that. We can use the precision member function on the console output stream. Set that to 4. Build a run. I'll put a new line in here just a second, but we can see the difference. Now the precision is going to be 4. So we get 4 digits now. Double 2 is actually going to get displayed in scientific notation now, whereas with the default display that will not, because we had a high precision of 6 by default. Again, the precision is 6. Even D5 now gets displayed in scientific notation, basically in the same way that we initialized it, 1.3e plus 0.5 right here. But there's a different way of setting the precision, and that is using the standard setPrecision function, which is in the iomanip file. In this example, I'll use setPrecision. I'll pass in 10 in this case. Remember, for double 1, this is 11 characters. Before we build a run, I'll just add that new line character, and I'll also change this here. Build a run, and now we can see that for double 1 we get more digits displayed, and then also double 3 actually displays all of its digits now. The output for double 1 ended with 5.4. That's because this is 5.35, so it's rounded up. I'll just show you that again. Down here, 6.54. Here we have 6.535.